This is Foundations of Math and Pre-Calculus 10, Chapter 9.2. We're going to be looking at systems of linear equations, and we're going to solve them using elimination. And elimination can make solving easier because you can avoid early dividing, thus avoiding fractions in your intermediate calculations. And you don't have to use this to solve. You can stick with substitution if you like, but sometimes it's faster to use elimination depending on how the equations look. And it doesn't matter which variable you eliminate, you should end up with the same answer. And note, computers and calculators use Gaussian elimination to solve systems of linear equations because it's faster than using substitution. So let's look at an example. Solve by elimination. And we multiply one equation by a factor to make the coefficients match with the opposite sign. So we can see that we can multiply the y in here by just a factor to make it match this and have the opposite sign. Now this is a mouthful, so it's easier just to look at what we're doing here first. We need to multiply this equation by 2, and we get 4x, 2 times 2x, and 2 times negative 3x is minus 6y, and you have to multiply everything. And 2 times 16 is 32. We just copy this equation over and line it up underneath. You want to line up the variables. And we have opposite signs. And what we want to do here is add the two together. 4x plus 5x, 9x. These cancel out, so we don't need to write 0. Add these two together, we get 45. So 9x equals 45. Divide both sides by 9. X is equal to 5. Now we need to substitute back. And we'll substitute it into equation 1. We get 2 times 5 minus 3y equals 16. Negative 3y, this is 10. Bring it over to the other side, it's negative 10. So 16 minus 10 is 6. So we divide both sides by negative 3. 6 divided by negative 3 is negative 2. And our answer is 5, negative 2. So if we can't find a single multiple, we have to multiply by the corresponding coefficients to get opposite signs. And the equation's missing here. We should have 3x plus 2y equals 10, negative 4x plus 3y equals negative 19. What we want to do here is multiply the first one by negative 3. So we're trying to eliminate the y's here. We multiply by the corresponding coefficient. So this is going to be negative 3, and this is going to be just 2. We need one of them to be negative. This one's going to be blue, and this is going to be 2. Okay, we multiply this one by negative 3, we get negative 9x, negative 6y, and negative 30. We multiply this one by 2, that's negative 8, negative 6y, and negative 38. We add the two together, draw a line. Negative 9 plus negative 8 is negative 17x. This is a plus. And negative 30 plus negative 38 is negative 68. And negative 68 divided by negative 17 gives us 4. And again, we need to substitute back. This is 1. We get 3 times 4 plus 2y equals 10. 2y equals 3 times 4 is 12. Bring it over to the other side, becomes negative 12. 10 minus 12 is negative 2. Divide both sides by 2. Negative 2 divided by 2 gives us negative 1. So our answer is 4, negative 1. Let's look at another example. And you should try this on your own. And then pause it and look at the solution. So what's easiest to eliminate here? We don't have to do anything. We just have to add, because these two are opposites. Draw a line. 2x minus 2x is 0. We don't write that down. Y plus 3y is 4y. 1 plus 11 is 12. Divide both sides by 4. 12 divided by 4 is 3. Substitute back. We'll substitute it into this one. 2x plus 3 equals 1. 2x equals 1 minus 3. That's negative 2. X equals negative 2 divided by 2. That's negative 1. So our answer, negative 1 and 3. Let's look at one more example. Again, try this on your own, and then take a look at the solution. So what do we want to eliminate? I suggest that we eliminate the y's rather than the x's, because we need to multiply the x's by larger numbers. Here, we need to multiply this by negative 5, and this one gets multiplied by 3. So we have negative 5 times 7, that's negative 35x. Negative 5 times 3y, that's negative 15y. Negative 5 times 16, that's 80. Sorry, negative 80. Multiply negative 6 by 3, that's negative 18x. 3 times 5y, that's 15y. And 3 times 9, that's 27. Add the two together. Negative 35 plus negative 18 gives us negative 53x. These two are eliminated. Negative 80 plus 27 is negative 53. Divide both sides by negative 53, and x is equal to 1. Substitute back into 1. 7 times 1 plus 3y equals 16. 3y equals 16 minus 7 is 9. So y equals 9 divided by 3, and that's 3. And our answer, 1, 3. So this is a bit of an enrichment lesson. We can solve larger linear systems using matrices. And so what we do is we just use the coefficients and leave out the variables as long as everything's lined up. So we have x's, y's, and z's, and the constants. So we enter this on a calculator. I'm not going to show you this now, but this is for your information since most of you don't have a graphing calculator yet. So we enter a 1, the coefficients 1, coefficients 2, coefficients 0, negative 1, and so on. And the function that we use on the calculator is called a reduced row echelon form operation. So we do the operation on matrix A, which is what we entered. And then we get 1, 0, 0, 1. Remember, this column is X, this column is Y, this column is Z, this is our coefficients. And then there's an equal sign in between. So X equals 1, Y equals -1, Z equals 3. And that's our solution. And we can also use this on our previous example, which is up here. So our X's are all lined up, our Y's are lined up, our constants are lined up. So we enter 7, 3, 16, -6, 5, 9. And that's it. And we use the reduced row echelon form operation, and we get X equals 1, Y equals 3. And that's our answer. So if you were to use this on a test, that's fine, but you should use it simply to check your answer. You need to go through either elimination or substitution to find your solution and write your solution down. And that completes this lesson.